A soccer ball is kicked at 10 meters per second, 40 degrees of elevation. How far does it go? So we have a ball, and it is kicked off of the ground with an initial velocity of 10 meters per second. And that velocity has a direction with an angle of elevation of 40 degrees. That means it's kicked upward and forward at the same time. Because it's subjected to gravity, this ball will immediately accelerate downward, so its path is going to look like this. The way we analyze this is we split it into components. We consider the horizontal component of its velocity and the vertical component of its velocity. We're going to use the vertical component of its velocity to determine how long it stays in the air. Once we know how long it's flying for, we'll multiply that by the horizontal component of its velocity and determine the distance that it travels whilst being in the air. Then we'll know exactly how far it's gone. I'm drawing this arrow here so that I can use trigonometry to solve the problem. What you need to understand is that the components of the velocity contain a magnitude and a direction, but not a location. So you can draw a vector for your analysis wherever it's convenient. See this vector here, this is the actual velocity. This is the x component of the velocity, and this is the y component of the velocity. If we draw this over here, we have a triangle that's real easy to solve, so we can figure out what those components are. So we've got 10 meters per second at an angle of elevation of 40 degrees. The horizontal component is going to be 10 times the cosine of 40. So that's my x component of my velocity is 10 cos 40, and my y component of my velocity is going to be 10 sine 40. Y is this cosine and y is that sine. You can review the video labeled SOHCAHTOA for clarity on there, but by the time you're doing these, you should be able to go straight to this. If you need to write the entire thing out, then I suggest you practice several of them and become competent with it. So 10 times 40's cosine is 7.66. And 10 times 40's sine is 6.43. So what that means is this ball has an initial upward velocity of 7.66 meters per second and an initial forward velocity of 6.43 meters per second. We're going to determine how much time it spends in the air by only considering the vertical component of its velocity. So all of this is purely vertical. Our displacement is 0. Now, why would I write in 0 for our displacement? We're talking about a soccer ball, and assuming the groundskeeper's done their job, that soccer pitch is level. So the ball is kicked upward from here, and then it lands here. It has a finite horizontal component to its velocity. However, the vertical component of its velocity is 0. Sorry, I should have said displacement. The vertical component of its displacement is 0 because it's gone up and then it's made its way back down. So vertically, there's no actual change in position from its initial position to its final position. That's why 0 makes sense here. Our initial velocity, and this is the initial velocity in the y, along the y-axis, or the vertical component, is 6.43. And why is this negative 4.9? It's because acceleration is 9.8 meters per second squared downward. And if we're going to call upward positive, then downward is negative. So our acceleration is negative 9.8 meters per second squared, and half of that is negative 4.9. Okay, you could use the quadratic formula to solve this at this point, but because our displacement is 0, we're going to leverage that and pull out delta t as our common factor. So 0 is equal to delta t times 6.43 minus 4.9 delta t, which leads us to two answers. Either delta t is equal to 0, which should just be obvious because if time is 0 and that ball is kicked after no time at all, it hasn't moved. Motion requires time. And if it hasn't moved, then it has not moved vertically, as vertical displacement is 0. Our other solution is that 6.43 minus 4.9 delta t is equal to 0. A quick rearrangement of this, delta t is 6.43 divided by 4.9. If you bring this to that side of the equation, they're both positive, and then divide out the 4.9, it gives you this fraction. And so time is, that's got to be completely wrong. My calculator's telling me it's 13. There's no way that fraction's 13. It's 1.3. So let me recap what we've done here. We have a ball that was initially kicked at 10 meters per second at an angle of elevation of 40 degrees. We drew a triangle and found that it was moving forward at 6.4 meters per second and upward at 7.66 meters per second. If a ball is moving upward at 7.66 meters per second, regardless of whether or not it's moving forward, it will be in the air for 1.3 seconds, because the entire time it's in the air, it's being subjected to gravity and therefore accelerating downward at a rate of 9.8 meters per second. So I now know that the ball is in the air for 1.3 seconds. However, I also know from our original analysis of the triangle that it's got a forward velocity of 7.66 meters per second. What that means is that the displacement in the x direction, the forward displacement, is the forward velocity in the x direction times time. So that is 7.66 meters per second multiplied by 1.3 seconds. This goes forward 10 meters. Well, 10 meters and 5 centimeters, 10.05. And that's forward. So, let me recap the entire thing. This ball was kicked forward and upward at a speed of 10 meters per second with an angle of elevation of 40 degrees. To figure out how far forward it landed, we took that initial velocity and split it into components. One forward and one upward. We used the upward component and the fact that acceleration due to gravity is 9.8 meters per second squared down to determine how much time the ball spent in the air. We then used the time in the air and multiplied it by the forward velocity to determine how far forward it went in that time.